Going live now! Exclamation point. So, I should be live and things are looking good. Good. And I can confirm the audio works as well. Great. So, hi everyone. Today we have a bit of a different setup because today I'm going to have to do a little bit of whiteboarding before I can actually explain what the demo is doing. It's been a while since probabilistic graphical models were popular. So the whole point of today is that we're going to maybe explain those a bit first, and then we're going to dive into what I think is a pretty fundamental, cool demo. In short, we're gonna I'm gonna highlight a new package that I made that you can play with. It's meant for demo purposes, not for production just yet. But we're also gonna talk about how Mimo is a core component in all of this. With that out of the way, we now get to enjoy a fancy animation. I'm using new streaming software, and this one has fancy animation, so that's super cool. But let's maybe talk about just a bit of a exercise in mathematics first, just to kind of get the brain going on what I'm going to be talking about today. So let's pretend that I've got two dice. So this is dice one, right? And this is a normal sided dice, right? So this is dice one. And then I've got this other dice number two. And again, these are both like normal dice, nothing fancy with them, but they are also independent of each other. It's not like the first die is going to influence the second die or something like that. Also, people that are tuning in, feel free to let me know where you're tuning in from. I always love hearing about all the places in the world that people like to tune in from. But anyway, given these two dice, I can actually come up with this other random variable. And that is that I'm going to do something like, hey, let's take the maximum value of dice 1 and dice 2, right? That's something I can do. And let's maybe also roll like another dice, let's say. Like this is something that I can do. And let's just, yeah, I'm going to sort of put a circle around it to make sure that these are, separate things. But this is sort of a mental experiment that I can go ahead and do. So these are dice rolls and numbers come out, and this is a stochastic situation, if you will. Well then, given this, I hope it's clear that if I were to maybe draw a dependency chart of sorts, that it would kind of look like this. And sort of the whole thinking here is that, they're all stochastic variables, but there are relationships between them. And that's basically because I've got this dependency graph. And maybe to put that a little bit more nicely, if I were to maybe make this into a sort of smaller graph over here. And again, I'm doing this just to save on ink. So I've got my two dice and I've got this one random outcome. So I'm going to call it R. I don't know, I'm just giving these nodes names, but you can imagine that I'm able to construct these sorts of graphs. And the whole point of me drawing a graph like this, it's more to declare how dependencies are related. I'm not doing anything with counting what kind of dice these things are. I'm not doing anything with probability theory in terms of numeric computation just yet. But the main observation at this point in time is just to say, look, what I can do is I can maybe make this drawing. And with this drawing, I am saying something about the probabilistic system. I am, in this particular case, saying D1 and D2 are independent of each other, but there is this R3 variable over here that depends on D1 and D2. That's basically what I'm declaring over here, and that fits the story that I've got over here. But to now move that more generally, and I'm going to keep the drawing on the left-hand side around, and I'm just going to start sort of erasing a few things over here. But, why do we have to stop at like a small graph? We can actually make somewhat larger ones. And like one thing I might be able to do is come up with some sort of a business scenario of sorts, right? So I don't know, I'm going to totally declare something on the spot here, but let's say that we've got a chance that you're going to be late for your flight, let's say. So this is like a delay. Let's use a white color for that. So this is like a delay for your current flight. What might that depend on? Well, that might depend on the delay of your previous flight, right? If your previous flight was delayed, that might have an influence on the delay that you've got now. And I don't know, maybe the time of day, maybe that has a dependence, right? So I can kind of come up with a graph that kind of looks like this. And again, there's like these arcs, right? But the interesting thing is, of course, that I can make a large graph like this, and again, I'm not doing anything with numerics. But one thing that I do think is kind of interesting, just from a modeling perspective, right, technically, you could also say, well, that delay of your previous flight, maybe that also depends on the time of day. Like, the thinking here is that if your previous flight was super early in the morning, well, then the odds of this flight being late, well, that's super small. And therefore, the chance that this influence is going to apply to my delay now, that might also be kind of small. So suddenly, by just having this idea of, oh, we can draw it like a graph, by having that idea, we are suddenly able to kind of doodle a model. Like, we can put a lot of model assumptions in just drawing this graph in terms of things that are or are not dependent on each other. And okay, like, one observation then that's really amazing is that if you have domain knowledge, that is going to be incredibly useful. Because a normal machine learning model makes it quite hard to say, well, these things do depend on each other and these things don't. In a normal machine learning model, I mean, if you do anything with scikit-learn, it's typically something like, well, I've got my x1 up until I don't know how many columns you've got, and they all kind of point to this y variable here, right? But it might be that xk also has an influence on x1 or something like that. Like, declaring that in a graphical model is relatively easy, but declaring something like that in a standard machine learning model is almost impossible. And what I'm now going to go ahead and do, sort of to get the juices hopefully flowing even more, is I'm just going to draw a random graph a little bit. Or actually, no, let's actually go back to the original example, because I think there's something I can explain with that one too. Yeah, that might be better. It might be easier. So again, I have my first node, D1. I've got my second node, D2, and I've got like that final random thing, right? But let's not, like, this is the graph, this is like the dependencies. But let's now play a slightly different game. Let's now say, well, suppose that I learn something about D2. Suppose for whatever reason, I know for certain that the second dice roll, that's a 5. Well, because I have that knowledge, I actually can update my knowledge on what this random variable over here is, right? I know that the maximum value of D1 plus D2, well, that's at least 5 because I've observed this guy, right? Oh, and what's also just kind of funny about that situation is because I now know something about this variable r over here, technically, I might also be able to update some of my knowledge on this guy. And that's for the simple reason that, well, there is still a relation, even though these two things are independent of each other, right? The moment that I know something about this outcome, technically that can also get me to update something about my belief over here. And to make that a little bit more intuitive, let's take kind of the extreme instead. Like, suppose now that I didn't know anything about D2 or D1, but I just observed this guy, right? Let's say that I know for sure that the value that comes out of that is a 12, right? Well, the only way that could happen is the maximum of D1 and D2 has to be 6, and this die has to be 6. Oh, so suddenly I have updated information about these two dice. Like, I can infer that. Like, with probability rules, I can actually kind of get there. And what's kind of interesting about that is that by writing down a graph like this, instead of it being a machine learning algorithm where, oh, there's inputs and that can maybe lead me to an output, you can also think about it more in the sense of, well, this is a system, and whenever I know something about like a node over here, then my belief over all the other states propagates through the entire network. And to maybe phrase that even differently, in this system, missing values are totally fine, and I can predict in any direction. And that's like a very sort of liberating thing to think about. Like in normal machine learning, it's always kind of, oh, a list of things, that's my input, and I predict one thing that comes out. But kind of the whole liberating thing here is that really, as long as you're sure about the graph that you drew, right, then that's a definition of a system, and then you can really ask any questions that you like about it. So I can really just do probability stuff here, right? Like I can write that letter P, like, if you take if you're from if you've done college probability classes, then this is what people like to write down, and you can do stuff like, hey, what's my belief now over D1 given that R is equal to 12? And if this graph was drawn differently, the way that you would compute this number would be different. But one like really cool observation is as long as you've got some sort of a way to declare a probability value like this, and you've got a graph that looks like this, and you've also got, let's say, a database or some sort of a data frame at least that has all the numbers that you need in order to actually calculate this number. Oh man, you kind of have a very flexible system. Like this is kind of the dream that people had back when they were talking about probabilistic graphical models. And if you think about like back in the old days at Coursera, there were two big machine learning courses. One of them was from Andrew Ng. He had this course on machine learning, and this other big course was probabilistic graphical models. And this was what that field was all about. And I'm going to be talking about a subset of graphical models, because what I will be doing is I will be talking about situations where I'm just talking about discrete distributions. So no normal distributions. These are just really discrete, only n options, and there's probability values attached and stuff. But I made a new library called PGM, because the abbreviation PGM stood for probabilistic graphical models, and I always thought it was kind of cute. Well, if we have a long name and we're going to turn that into a short one, maybe it'd be fun to turn it into a long name again. So the library is called PGM. The whole point of the library is that you are able to do exactly what I just said. You give it a graph, you give it a data frame, and we can do all sorts of counting. And then the API tries to be as close as possible to the mathematical notation. That's the goal of the library, so to say. And as we'll see in a moment, a really cool thing we can do with Mimo is we can also make this graph be an input that you can draw. Because Mimo is interactive, I can come up with an interesting DAG visualization that allows you to just doodle the edges based on columns in a data frame. And something about that is also just quite liberating. So if you have a little bit of background in Bayesian probabilistic models and stuff, like some of this stuff might be more appealing than if you're maybe more of a newbie. But hopefully this introduction captures a lot of ground in terms of surface area of like, hey, what is this work really about? So hopefully this got some people excited. I might move on to like some details in a bit, but if people have questions at this point in time, now would be an excellent point in time to start asking, because I'm going to be moving away in a moment to something else. Also, by the way, like if you ever need to do like an online presentation like this, there's this website called TL Draw. Oh my goodness, it is amazing. It has light mode, it has dark mode. Combine it with a doodly pencil like this, you can zoom in and out. It is just so good. It really is just so good. But again, there's no questions coming in, so I'm assuming like the mathematics of it and sort of the elegance of having a graph and the way that the inference can kind of go. I hope that that's clear now and also kind of appealing to some people. And again, like the thing that we really love is the fact that I have a system declaration, and from there on, I can ask any question that I like. In a normal machine learning model, you have to train the whole thing in order to predict one variable. In this particular case, we're saying, no, we're going to fit our system, and then we can ask any question that we like. So the model is both very bespoke in that sense, but it's also quite articulate. And we can deal with missing values. That's also something that's totally cool. About the missing values bit, by the way, just one detail on that, and then we're going to move on to API design. But like, imagine if you would, I've got a node over here. Yeah, let's call this a random variable 1. I've got this other node over here, random variable number 2, number 3, and maybe, I don't know, number 4, right? Like one, and let's say that they're connected this way. I've got a good reason why they have to be connected this way, but let's say that this is the way that they are connected, right? I mean, one thing that is kind of cool is that suppose now that I'm interested in knowing something about this variable over here. Well, if I know this variable, and if I know this variable, I kind of don't care at all if this one is missing. Because all the influence that that variable could have on this variable over here that I would like to get out, that is kind of blocked by these two variables over here. Because that's there's no real influence that can go past x. So there's no real influence from 4 to 3 that isn't sort of captured by 1 and 2. Like, if you think about causal diagrams, that's also something that hopefully makes sense. But it also means that for some queries, if the data is just kind of missing, that's also just totally fine. Partially because, the inference graph says it can be blocked. But also, imagine it's training time, for example. imagine that I've got a table, right? So this is my, let's do that in gray. So this is the data frame that I'm actually learning from. And I've got x1, x2, x3, and x4. And let's say that there is like this one row over here that has numbers for all of them. So like 1, 0, 1, 0, or something like that. Well, you can imagine that if I have such a row, and let's call this row 1, that one row is going to be able to update this relationship, this one, and this one. Like all the relationships get some sort of an update because there's values for it. But now let's imagine that, I don't know, for this row, x3 is just missing. So x3 is not there. The other values are totally there, and that's for row 2. So I'm going to put a 1 here to indicate that, well, put a 1 there. So again, this is one of those situations where row number 1 is able to have an influence, is able to update the way that, is able to update the numerics behind the graph you see over there. Oh, fell off the microphone. And we're back. But now, if you consider that row number 2, well, row 3 is missing. So that means that row 2 cannot have an update to anything that points or leaves from x3. Oh, but if I want to update my belief from x4 to the other two, oh, that is actually possible, right? Like in order to update my belief on what should happen with that one arc, even if there's like this one row missing, like having a variable that's just missing basically means that for that one row, we cannot add extra information to an arc. But we can still totally learn for the other arcs, right? And this is also something that's kind of curious with machine learning. If you consider a basic machine learning model, even something like XGBoost and stuff, they do have fairly intelligent ways of dealing with missing data, but that's something that had to be patched on top, as opposed to, well, the graphical nature just deals with it because it's a graph and it's fine. Like something about that I find to be extremely, extremely elegant too. Like, especially if you consider that there are lots of these moments where it's not just at inference time when we don't know things, it's also typically at training time that some of the information is just unreliable. And having a graphical representation basically just means, oh, we just allow for that. And something about that, I don't know. I would love to have that in real life systems. It's just the one thing I'll say. So hopefully people thought this was also kind of a cute observation about these systems. Like we are, every time we see more data come in, we are updating the arcs, so to say. Like what's the relationship between these two nodes? That is the thing that we learn from the data. And then afterwards, we can ask all sorts of questions. And because that's the way it's trained, and because we have independencies and all those sorts of things, that's also why we can deal with missing data. It's both train time and inference time. And that's also just super duper cool. Okay, some questions are coming in. Kate, if I forgot what R is, can you go? Oh, okay, someone already answered that question. Great. Cool. So, okay, like you can imagine now, I've basically set myself the mission of, hey, I want to be able to do stuff like, hey, I want to have some sort of a variable, right? So I have this one data set. Let's maybe introduce it. There is the smoking data set. And in the smoking data set, there's one column called smoking that says whether or not you are smoking. There's this other column called age that basically tells me how old you are. And there's this other one called outcome. And that tells me if you are still alive in 10 years' time. And I don't know the source of this data set. It might be like one of these made up ones for teaching statistics. But let's say that these are the variables that I've got. Well, then in Python, what I would like to be able to do is have some sort of a function p. And again, I want to really stick to the mathematical notation. And then I would really like it if I would be able to do something like, well, you know, what is the probability that the outcome is that you are alive? I'm going to use mathematical notation first, and then we're going to talk about Python. Given that smoking is true. Smoke is, and I'm just going to put T there for true. Like this is the mathematical way. This is math notation. If we were dealing with pen and paper, this is how you would do it. Cool. Okay, but that's kind of doable in Python, right? So if I just highlight a few things, like, okay, we need some sort of a function p. Let's start with that. So I need some sort of a function p. Okay, Python has functions, so that's good. We can just sort of do that. Okay, but there is one bit of notation that I am going to have to change. So equals, that is variable declaration. We can't use that, but I think double equals is fine, because in Python what we can do is we can overload these operators. So equality is one of these things. So I think if you declare, so you have like this def dunder eq, right, on a class definition self, and then you can compare that to something else, like some sort of other thing. Okay, so that allows me to take something that's called outcome and compare that to some sort of a string, and what that exactly means, that's an API translation, but I am going to have to accept that the equal sign is taken. So, okay, I'll just use double equals. That is then, okay, so that's still able to work. Oh, and there's actually a funny thing. So the same thing is actually the case with this straight bar. So this straight bar is also an operator in Python, and oh, that is actually something that I can also override. If I want to do that, though, I'm going to introduce yet another change, because what I don't want, like, I don't want to compare this operator to like a string over here. That's going to be painful. So I will need to introduce brackets of some sort. Okay, and then what I could maybe declare is that I have some sort of a condition object. And that condition object knows how to deal with this pipe operator. And I've got another condition over here. And the whole point is that, like, if I were to merge condition objects like this, there will always be some sort of notion of a left-hand side and a right-hand side. And the thing that's on the left-hand side, that would be the stuff over here, that is the stuff I want to calculate. And then the stuff on the right-hand side, stuff over here, that is information that is given. But okay, like so far, I think we can kind of get there, because the only thing I need now, like the final missing piece, is I need to make sure that these variables over here contain everything that they need in order to A, eventually do the calculation, and B, I need them to be able to turn into these conditions, so to say, and then the condition object can deal with the bar object, and then whatever object comes out of that, this function P needs to be able to deal with that. So okay, like there's a path towards being really, really close to the mathematical notation here. There are still two things missing, though, and that is that, you know, as I said earlier, we kind of need a few pieces. Like, one of the pieces that we need is this mathematical notation, but there's still this notion of a graph and this notion of a database. So we're getting there, but we're also just not quite there yet. And one observation that it took me a while. Like, this is actually a problem I've been thinking about like for a year. It's just that I've never really been able to like, what's a nice API for this? And then I had one of these like cafe moments where I'm like having lunch and eating a Dutch egg sandwich, and then it just sort of struck me like, oh, actually, like, we need these variables to just know about the graph and the data set. So one thing I could do is I could come up with some sort of a DAG object, right? And the DAG object, it needs to receive some sort of a data frame that has, let's actually spell it. So data frame, dframe. So I need to have some sort of a data frame with discrete values. And what I can say is, well, all the variables that I might want to calculate, those are columns in that data frame. So okay, that's what we might be able to do here. And then what else does the DAG need? Well, I already have my nodes. I already have the data. The only thing I now need is the edges. So that'll be a list of tuples that combine like source sync, like from to, like all the arcs. Those are just tuples of column names. And this will give me a DAG object. And kind of a funny thing that I could do is I could say, well, I can attach a method here called DAG dot get variables, right? And what'll that do? Well, that'll just take all the column names in this data frame, and it'll make a variable for each of them. And if you were to call this from like a cell or like a REPL of some sorts, then you would be able to also in the representation see the actual name of the column. But this will allow you to basically do something like, okay, smoke, age, and outcome equals, and get, yeah, like, okay, now I have these variables, and that variable can still remember the DAG that it created. Oh, and that DAG that created it, that also still remembers a data frame. Okay, great. So I can still bake the information that I need in here. And from here on out, it's an implementation exercise. But like, this was the main realization I had at my cafe. Oh, if I want to have a notation like this, then the only thing I really need is I need to have variables that are able to carry everything that's necessary. And the way you get there is by first making a DAG and by then adding this get variables method. Like that was the main conclusion. Like the moment that you're able to conjure up this, then getting here, at least theoretically, that's the path forward. So any questions about this? Like this is a little bit more of an implementation thing, an API design thing, but people don't take enough time when it comes to stuff like this. Like I really like to think about, hey, there's a library, it needs a user interface. What's the user interface is just nice. And I really like to take a lot of time on the API design phase, such that if I come up with an amazing API, then it'll also be a joy to use after. And I've seen it happen so many times that people worry about the implementation first. And nowadays, maybe it's also because I'm a little bit more senior, I worry about implementation later. What I really like to think about more is, oh, is the API just amazing? And is the API going to allow for the thing I'm interested in? And in this case, the answer is yes, because I just need these variables. And with those variables, I can create conditions. And with those conditions, I can have some sort of a function that knows how to deal with conditions, as long as the DAG state is just being passed forward all the time. So at this point, I hope that I've made all of you excited and that you're now wondering, like, Vincent, show me the demo. But I also hope that people agree that like these insights matter. Like API design, we shouldn't forget about that. And also look at how pretty the notes are. Like again, TL Draw, it is just stellar. It is amazing. It is the best. So, quick demo. So this is a notebook. Unfortunately, in order to run this notebook, you need to run it on an actual Python machine. You cannot run this in WASM mode. The library that I'm using has a couple of these pre-compiled bits that aren't compiled to WASM just yet, and I also don't think they ever will be. There is a library called PyPGM, and let me just, I've built this on top of that, so PyPGM. Yep, that's the one. So a Python library for causal and probabilistic modeling using Bayesian networks. It's a library that's been out there for a while, and it really is elaborate. The one thing I will say though, if I just look at some of the examples, so discrete networks, right? I don't like the API as much. So yes, what you can do is you can say, hey, here's a discrete Bayesian network, and then you can come up with these tabular, distributions. Like for every arc, we're going to make a distribution object, but you got to do that manually. Like that's the thing I didn't really like about it. So the first thing that I did, and this is definitely done with vibe coding, is I made a system that takes the API design that I like and is able to turn that into all the code that's needed to do inference in PGM. However, you will never ever have to make these tabular conditional probability distributions manually. Like that's something I didn't want you to ever have to do. So the API is literally this. From PGM, you import DAG. You can say DAG equals DAG, and then you have to pass the you have to pass the nodes manually here because it might be a subset of the data frame. But the whole point is still you get the data frame to come out like this. And I'm actually kind of proud of this one. You are also from here on able to basically just do stuff like this. So there's this function p that you can also import, right? But this is literally the syntax that you can go ahead and do to get probability distributions out. And if you really wanted to, you could even turn it into LaTeX. That's something I've added later. But this is the way that it works. And also just kind of a fun fact, this is totally a hack, by the way. Suppose that you've got a column like age, right? And let's say you do the bucketing thing. So you've got an age group 10, you've got an age group 15, and you've got an age group 20, and you basically bucket it by every 5 years or so. So if you've got something like this, and I were to ask you like, oh, can I get an age group larger than 20? Well, then as an intermediate step, it's first going to make a bucket column, such that you can say like, hey, this predicate that's either true, other way around. That's either false, false, or it's true, right? So there's all sorts of stuff I can sort of hide away from you. Normally, I would assume that everything in here is discrete, but if you are dealing with an integer, then this is kind of a in-between little hack such that I can make it feel discrete enough if you're interested in doing things like this. So that's definitely in here. But, okay, we're in Mimo, so we can actually maybe do the demo proper. So what I figured I might do is maybe cut this whole thing up in a few pieces. So what you're looking at here is, let me see if I can show you the actual code that generates the DAG and all of that. Yeah, so there's this DAG over here. So I'm saying DAG equals, let's zoom in on this. I have this tool called Edge Draw that allows you to draw edges on screen. So I can grab the nodes from that, and I can also get the edges out. So the definition of a DAG is something that you can draw. And I pass it along this one data frame that's all about smoking, and here's what that data frame looks like. This data frame is just, there's an outcome, you're either dead or alive, you're a smoker, yes or no, and there's an age. And these are bucketed, I think I've bucketed this by every 10 years or something like that. But this is what the data frame looks like. So what I can then do is I can say, well, let's now say that there are no relationships whatsoever. So when I do that, there's this one probability, no matter if you're smoking, no matter what your age is, there's this one probability that you'll still be alive in 10 years' time, and that is a little bit over 70%. Aha. But let's now say that the outcome of whether or not you are alive, whether or not that depends on being a smoker. And when I do that, I have this table over here with all the probabilities that updates, but also this graph over here. And notice that in this particular case, if you are a smoker, and age has no influence on anything whatsoever, but if you are a smoker, then smoking is actually good for you, as far as like being alive after 10 years goes. And this might initially surprise you a lot. This is like a very brilliant lesson in statistics. And that's because whether or not you're smoking doesn't tell you the whole story. Like, age is also pretty important here. And the reason for it is that people who smoke are typically younger. If like, it's a bit of a characterization what I'm about to say, but if you're single and you're in a bar, if you want to meet people that you might want to partner up with, then something about hanging out with the cool kids that are all smoking, I don't know, that's like behavior you might do in your 20s and maybe less so in your 50s, right? Okay, so this is characterization. It's not necessarily the whole story of smoking, but you can hopefully imagine that there is it's a bit like cheating to say, oh, whether or not you're alive, that only depends on smoking. I'm saying no, it also depends on age. And when you do that, then suddenly this graph looks a whole lot different. Now suddenly, being a smoker, like, also note, by the way, that the probability of being alive decreases as you get older, which is also something I would expect. But you can also see that now, if you normalize for that age, then suddenly smoking is detrimental for your health as far as being alive after 10 years goes. And again, like, the thing that I just thought was really cool, and it's a bit of a shame that yeah, so I have to zoom out a little bit, so sorry about that, but like, I can click an arc if I want it to go away. But something about, hey, like, having these charts, and in order to build these charts, I'm using that notation over here, right? Like with the probability and the outcome and whether or not you're a smoker and all that good stuff. Like, it's really cool that I'm able to have an API like this. But notice how that's almost small beans compared to being able to draw a graph. And that's, I think, the interesting, and also, in my mind, the main point that's the most interesting thing about this library. So, if I just do age, by the way, then it all falls down. And if I say smoker and outcome, okay, that also makes sense. What if being a smoker, is that dependent on age? Well, if I do that, then, oh my, being a smoker, that really makes it better for you to be alive. Oh wait, that's actually kind of weird. So oh, I can come up with unit tests that should not be broken, that help me inform what the logical graph here is. But notice how, oh, what I'm using, so people are asking like, hey, what are you using here? To draw the graph, there's this, I usually like it if a library sounds like a Pokemon, and I had this one library in mind for me with like all sorts of widgets that I could go ahead and use in notebooks, in particular Mimo notebooks, of course, but these aren't any widgets, so they will also work in Jupyter. And originally I was thinking of stuff like, let me just show you like some of the things that are in here. But like originally I was thinking about things like, oh, maybe I want to have like a 2D slider, or maybe I want to have a slider that's like, yeah, I can show you here. So here's a 2D slider, and I can change 2 dimensions at the same time. And this is one of those widgets that I just wanted to have around. And similarly, oh, maybe I want to have like an array and a matrix, and I want to have that around. And oh, that's also fun to play with. And There's a PCA demo. There's also these tangle objects that I'm a fan of. These are sliders that you can basically hide in your markdown. So it's just highlighted text, and quite natively, you can mix and match markdown stuff with interactive graphics that update. So notice how the graph updates by me just interacting with markdown here. So there's all sorts of like widgets and wiggly stuff, and it sounded like Wigglytuff, which is a Pokemon. That's kind of the joke of the library. But the library is called Wiggly Stuff, and there's like all sorts of general widgets in it. And one of the widgets, like last week or like 2 weeks ago, someone added a color picker, by the way, if that's something that you're interested in. But in there is also an edge draw object, and that just allows you to draw edges. It uses D3 under the hood. This is also the reason why I couldn't do this demo in dark mode, because I forgot to implement dark mode for this widget. But you can see that as I draw like edges between these things, right, this JSON object down below updates, and that's Mimo reacting to a change. And I can also click the arc to make it go away. But what I'm using under the hood here is Wiggly Stuff, and in particular this edge draw functionality. That's what I'm using as a component over here. From that component, I'm doing all sorts of calculations. Out of that comes this one Altair chart over here and this data frame. I don't think that that's necessarily the most exciting bit, but the main thing that I think is just exciting, and like that's the main sort of weird conclusion I had when working on this, is if I were to look at stuff like this, right? Like, oh, the probability of an outcome given smoke equals yes, right? Like stuff like this. The fact that you can really elegantly put that in code. People like to call this a domain specific language, right? So that's a DSL. It's like a thing that people like to say. And in this particular case, it's not actually like a different language. It's just using Python, but this is like syntactic sugar, I guess you could call it. But a lot of people value this. Like if you're in a specific domain, it is really nice to have a language that you can talk to that does the thing you're interested in a very concise and bespoke way. So you could, okay, the probability formula, if we can do that from Python, people like to say that's a domain specific language. But what I'm doing here, that's not a domain specific language. This is a domain-specific interface, and that to me is just so much more interesting. And like it's not just the fact that we can do this with probabilistic graphical models, but also like LLMs and stuff. Like, oh, I want to have some Python code here, and maybe draw that thing there, and oh, I want to interact all these things together and build that real quick. Like that's the really cool thing at play here, and Mimo is really well suited for that. But like, I do want people to observe that it's one thing to come up with a really fancy API and to sort of say, oh, that's a really cool interface you got there. And yeah, that's great. But it's even better if you consider a domain-specific language is kind of an amazing building block for a domain-specific interface. Because to me, the real learning and exploring and understanding the dataset comes from toying with this graph and building good charts around that really matter for your business case. Like that, I think, is way more interesting than typing stuff like this into a terminal. Even though I like this, right? Like, don't get me wrong. Like, I really think I'm really content with the moment in the cafe where I was able to conjure all this stuff together. But the really amazing thing to me is the combination of it all. Like, that's the main point I really want to drive home here. Like, it's cool to have this, but it's great to be able to wire things together, because that's when some of the more amazing things tend to happen. And it's a common theme. Like, this is just for probabilistic graphical models, but there is this idea in my mind that maybe we should move away from domain-specific languages. We should keep doing it, but the real magic is in domain-specific interface, or like environment or something like that, that you start building those for yourself. That's the thing that I think more people should do. Anyway, there's another demo I have for this. I just want to make sure that if there are any questions about this, because I have been going through this relatively quickly. So let me just check. Awesome. I'm currently transitioning to Mimo for my professional stuff. Happy to hear it. Yeah, so one comment. So someone is saying this uses Mimo, which wraps around libraries like matplotlib, Altair, and Plotly. I think we don't wrap around matplotlib as much. And also over here, I'm not really using any of the fancy features for Altair. This is really just using base Altair. There is a thing inside of Mimo where you can do marimo.ui altair_chart. And this allows you to make selections in the chart. And those selections can then be used like to update other cells and stuff. Like we definitely have support for that. And Plotly has some support for that too. But we don't wrap around matplotlib at the moment. Unless I'm mistaken, like we tend to make like 3 releases a week, so it could be that I'm behind and wrong already. People are asking a question: do we support auto completion in SQL cells? And yes, we do. So let me just see if I can get that. Let's make this a SQL cell, and select star from df. Yeah, let's see if we can grab something from the smoking data frame. It does tell me that I need to install some stuff. And maybe if I run this now one more time, I have to install Arrow. No, this works, so that's fine. And I think now I should be able to do like outcome. Yeah, okay, so this one is, I think this one is not able to do because it's a local data frame, but if I were to go to the data sources patch, should be able to. I need to double check this. It could be that do I have my LSP turned on? User settings, labs, language server protocol. Okay, so it could be the case that I need to attach like a proper database connection, which I haven't done here. Like that could be the reason, but there's still some auto-completion here. I've definitely seen the thing happen where, what are the column? This is the AI support thing. Like, what are the column names in @? And then I should be able to do like df smoking. And if I were to do this, I have to install Anthropic. Yes, sure. And then if I were to retry it now, then I think, yeah, okay. So like it is, you are able to @ and then a variable name and then use that in other utilities inside of Mimo. In this case, I'm sending it to Anthropic and asking it to do LLM stuff with it. And it is also able to read some other stuff that I've got in my notebook. So it's able to infer indeed that this is the stuff that I'm interested in. If you don't like, you have to check the docs about that SQL completion stuff. I do think we support it. It's just, I think I've got a flag turned off. But yeah, a great question. Oh, and people say it's such a flex. Well, the thing is, I can really just install anything because this is a sandboxed environment, by the way. If you really want to see a flex, you're kind of challenging me to flex a bit now. But okay, ultimate flex. This whole library, by the way, like this entire pip installable library, that entire library is developed from a Mimo notebook. Like, oh, hang on, shortcut broke there. Let me move my cursor down. So let's close this. This is my local cursor environment, and you can see that I'm running the notebook. Notice how there's a folder here called NBS for notebooks. In there is a Python file called dunder_init. That Python file contains the notebook that you're looking at right now, and there is a build script that is going to take the notebook and turn that into a Python library. The reason here partially is that I really like to develop inside of Mimo notebooks because then I can have charts around and, you know, it makes sense for some numerical things that I do. And then once it all works, I can sort of move that out. So I don't think I think right now I've moved everything out into here. But the way that this was developed originally was with a Mimo notebook. And notice that I just installed Anthropic. Biggest flex is that Anthropic is now part of the dependency chain of this notebook. So this script stuff on top, this is something that UV can pick up, install in a local sandbox environment, and that is also what Mimo does under the hood if you run these notebooks in edit mode with a sandbox flag. Super sweet feature. I use it all the time. But yeah, I will also say, like, I have noticed with the whole vibe coding thing, I like to play with Windsurf, I like to play with Cursor, but inside of a notebook, I really still like to do the coding myself. But for like occasional functions, that's when I still use the chat tool here. So one thing I, just as a demo, give me a function that I don't know, calculates the Fibo sequence. Like that's kind of the demo. A really cool feature is you're going to see it generate a little bit of code here. Oh, and yeah, there we go. Stop scrolling down. There's a copy button, but there's also an add to notebook button. I can click it, and then this is immediately added as a cell, which is kind of nice. And also, as I said before, like you can reference variables and things in your notebook here. So again, I really like it if I'm able to do all my coding by hand in the notebook because it usually involves my own creativity and domain knowledge. But having access to some of these AI tools, so like that one quick thing I want to add, like, I don't know, Python image object turned into a NumPy array with a certain color code, like something I needed the other day. Like stuff like that is still nice to have around. But anyway, Enough about that flex. Let's just check. Yeah, we still have time for one more demo. So this dataset was age and smoker and outcome, but I figured let's do a final demo on a somewhat more interesting dataset that has a couple more just variables, really. Let's check. Did I just get a text message? Okay, so I can ignore that. My kid just fell asleep and the babysitter's wondering what to do about it. Nothing is the right answer. Okay, so this is a different data set. This was a university in Italy. And at this university, they did this one interesting experiment. They said, hey, half the students, please deprive yourself of sleep. Like, they all said yes, right? So they weren't forced to, but that's what the sleep variable is for. Did you deprive yourself of sleep? That's what that variable means. Besides tracking whether or not you were sleep deprived, they also checked, hey, did you have a high GPA? Like, are you a pretty good student or are you average? Like, that's what the GPA hopefully tells us. But it doesn't, like, that's unrelated to whether or not you were sleep deprived. They really tried to sort of keep that in balance. Given that, they then gave them some tests. So they said, hey, you have to, I think, implement Pig Latin in Java is what I think they did. And then they had like a couple of checks that they wanted to do. So how many of the... So I think what they had is they had like a couple of tests that were visible. So they said, here's a couple of assert statements and they have to pass, and the students were able to see those. There is how many stories were they able to actually accomplish, I think in an hour. Like that, a couple of things that had to be implemented, and like how many of them did you complete, that's a variable. And then there were also some unit tests that they just never showed to the students, but they still should pass. Like if you have a good implementation of Pig Latin, there's a couple of these edge cases that you got to capture, but some of those were blind. Like the students only saw a subset of them. I think those were the asserts. I could be mixing them up, but if I were to now maybe think and turn this into like a graph, I mean, I think sleep, like whether or not you had good sleep, that will definitely have an effect on, did you get many of the asserts right and all that stuff. But I can also argue that like having a high GPA might also sort of influence that. So if I were to maybe think about the graph that I can come up with here, right, I think this is sort of what it would look like. And then I can sort of have a look at these two charts. Like, I think the way that I've set this up is this chart over here. Yeah, this is if you are sleep deprived, and this is if you are normal. Yeah, so this is sleep deprived, this is normal. And then this is also that you have a high GPA, and then this over here is that you have a low GPA. And then we can have a look. Okay, how many got like a bad score on everything, and how many got a good score on everything, right? Like those are two extremes, and we can sort of compare. Turns out that if you were sleep deprived but had a high GPA, the probability of like flunking on everything is about 60%. So these are on average good students, but when they are sleep deprived, oh boy, do they start failing. But if I say let's now compare that to people who did get their sleep but who were like not high GPA performers, well, the probability of flunking on all three, that's actually kind of small. The probability of getting everything right is 16%, which isn't super duper high, but it is still way higher than what you see over here. Like the probability of getting everything right, even when you're a high GPA student but you're sleep deprived, that is like super duper close to zero. And again, part of what's happening here is I have a very elegant way to ask this question. Like I don't have to think about the SQL query that you have to write here, right? So that's definitely kind of cool. But all these numbers will be different if this graph was different, right? Like if I were able to maybe, I don't know, like if this was a much more complex scenario and there'd be like lots of nested things out there, like you would have to maybe draw up something that's a bit more complex. But again, the reason why it's easy for me to reason about this, and the reason why I'm able to sort of be very flexible about the questions that I can ask, that's partially because of the model choice. Like probabilistic graphical models allow for missing values and asking questions at any point in time and doing inference proper. Another good part of it is that I'm still able to write Python code, and having a DSL available there is like, again, super duper nice, right? But don't underestimate the interactivity here. Like being able to draw this freaking graph, it's such a small thing, but it makes the world of a difference. Oh, and people are okay. So okay, that's the end of my rant there, I suppose. But now people seem to be asking on whether or not I'm able to talk about state-of-the-art Bayesian frameworks. I'm not the right person to ask, really. So I believe that you have Pyro on top of PyTorch, and you've still got PyMC3 that I think is still I think they're called PyMC now instead of PyMC3. But like the PyMC people are definitely still doing things. Like those are, I think, my impression is that those are the two main libraries that still get plenty of support. So if you're interested in doing Bayesian stuff, definitely check there. It's just that those libraries are a little bit more bespoke, because what I'm doing here is relatively simple, right? Like I'm just doing discrete stuff. So everything that I do here can be done with counting, which is why I can vibe code something around the PyPGM library to do the heavy lifting for me. If I wanted to also be able to say, oh, and by the way, this node over here that has a normal distribution, and the way that that's dependent on high GPA is via this other distribution, and then you suddenly need way more code in order to get there. So like, I'm definitely going after an easy case here, which is like fair to observe. But it also means like I still like I've done a lot of PyMC3 like a couple of years ago, but I've also not really used it for the last 3 years much. So I wouldn't be the person who would be able to tell you whether or not state-of-the-art stuff is actually happening inside of PyMC3. I would imagine that it is, because there's some senior people in the project and there's a company behind it now. But yeah, this is more about API design and also interface design. That's more the thing that I'm trying to achieve here. So I'm not going to talk about state-of-the-art Bayesian frameworks because I haven't been able to do a good deep dive on that. Right. So someone is asking, like, what does this P thing actually return? So let's just show that, because that's a good question. I should have shown that earlier. So I've got my big query over here, right? And I'm asking for these three variables given sleep deprived and high GPA, let's say. What I get out is a list of dictionaries. So these are basically looping over all the events, like all the possible values that these three variables could potentially, in a combination, generate. And then there's a probability value behind it. That's what I'm generating here. So it's just, in a way, these are like the discrete probability values. It's just a list of dictionaries. You can quite easily turn that into a data frame if you wanted to. I can also just turn this into a oh, I had a different to LaTeX. That's also something you can do if you're so interested, right? Like, and then I have to sort of, because this is Mimo, I have to turn that into Markdown, because then LaTeX support is actually there. Oh, and text equals, let's do this the formal way. I gotta do the proper syntax. Something like that, right? There you go. So this probability distribution is a discrete distribution, and I'm going over all the different values of many tests, many stories, and many asserts. And yeah, like the most unopinionated way of returning that to you in my mind was to give you a list of dictionaries, and then if you wanted to, you can also turn that into a data frame. And these probabilities all sum to 1, if I'm not mistaken. So if I do sum here, they do, okay, numeric tomfoolery aside, they sum to 1. And then, okay, and people are PyMC3 is very much following the state of the art. Yeah, I would not be surprised by that. I think they've got a source of funding, and I think they do a lot of consulting. I think sometimes I talk to people from that group at PyDatas and stuff. And Bayesflow is something apparently amortized Bayesian inference, and you can choose your backend, PyTorch, Keras, or JAX. You can find a simulator. Yes. So does that mean this looks pretty good? It does feel. Let me look at the syntax. I do feel like this is one of those libraries where it really helps if you know the material. If you're like a super duper newbie, you might have a hard time learning this. But they have some examples, so that's always good, like linear regression, Bayesflow. Yeah, they have a simulator, and they do the MCMC thing, I think. There's an adapter. And there's charts and more charts and more charts. No, this is okay. This is kind of 2 moons bimodal distributions, right? This is definitely more fancy. Okay, so there's definitely there's more happening in the space than I was aware of, which doesn't surprise me because I was really only focusing on the interactive bit here. But yeah. Like one thing I do want to maybe mention, which is I think the best observation here, is again what I'm doing here is limited and constrained. I am only doing discrete distributions, and that makes this whole thing so much easier. If you really wanted to get into, oh, I want to combine discrete stuff with continuous stuff. Oh, and for the continuous stuff, I want to have all these distributions and have support for all of them, including the ones like Dirichlet, which are not differentiable. Things do become a whole lot harder, right? So the stuff that I'm doing in this library over here is definitely more of a demo, and it should not be seen as, oh, don't use the other libraries. Like, totally use the other libraries. This library also has very little unit tests, and this is more meant as a demo, right? But the main thing I do hope to get across here, just as a, I'm partially sort of here because of Mimo. Having a DSL is great, but being able to build an interface on top of that, that is also something I would not underestimate just how valuable that is. Yeah, one thing that could be interesting actually is if you could maybe, I need to know more about PyMC3 and how that would actually work, but because I think in PyMC3, in a discrete case, there's only one way to do the calculation, right? Like an arc can only be calculated in one and only one way because it's just discrete. And unless you're assuming things like beta distributions, which I'm not, I'm just doing uniform stuff. If you can assume everything is uniform discrete distribution, the graph is kind of all you need to define the model. That's not the case if you're doing stuff with PyMC3 necessarily, because the type of distribution and like there's way more details that you can configure. It will be interesting to see though, if you can maybe draw. Yeah, that could actually be kind of a cool feature with PyMC3 actually. Like you could draw maybe a graph like this that tells you like, hey, as a user, this is how I think the dependency should go. And then this drawing can kind of become a unit test for the model that you have in PyMC3. Like it might be that in your code, you've written it in such a way that actually things that you didn't, like there's an accidental dependency or something like that. Like that you could maybe make this drawing into a PyMC3 unit test. Like that is actually like a thing that could be interesting. Oh boy, and people are starting to talk. So yeah, what will be cool is the text API stuff to work with MCMC examples for PyMC3 example. Yeah, so I think that might be a fun thing to explore. Note, in order to do that, you don't need this PGM library. You like edge draw is basically all you need there. So feel free to just use Wiggly stuff directly. I hope that company. There's a potential, I feel. I mean, if people want to toy with it, definitely feel free to. I can't guarantee how much time I'll be able to put in that project, but if people dig the demo, for sure, run with it. There's a gap between conditional probability Bayes theorem and then moving into PyMC3. Yeah, I mean, like one thing with PyMC3 in general, like the thing I would sort of keep in the back of your mind there, like what's the use case for PyMC3? Like when would a company actually start using it? Because we have TensorFlow and like all those other libraries. The thing I would argue the thing I remember from doing PyMC3 back in the day is you can really articulate the way the model should behave. And that articulation also makes the model bespoke, because what you can do is you can do inference with probability distributions and like uncertainty intervals, and you can do all of that. But while you're doing that, you can also inspect the model, and then you can do things like inference testing. So to give you a example, like the example I always like to give is, let's say there's a chicken data set. And there's a chicken, and different chickens have different diets, right? Like one thing that you can do, if you build a model that tries to predict the weight distribution of a chicken as it grows and as it gets like a certain diet, you could argue, well, you can build a system in PyMC3 that will help you predict that growth curve. But once you have that growth curve, you can also use it to do inference testing in terms of, oh, which diet is best, and does that depend more on the time or does it depend more on the diet? And you can actually calculate with proper distributions and stuff. So you can kind of do hypothesis testing as you're modeling. Like that's kind of the moment you realize that's also kind of the moment when you start recognizing that PyMC3 does a trick that very, like those kinds of tricks from the Bayesian field, that is very hard to do in normal, even linear models, if you think about it. But that's the main thing that I would try to keep in the back of your mind. Yeah, no. So if there are PyMC3 people who afterwards are keen to maybe play around with this, like definitely I would love to see a blog post on like how maybe wiggly stuff and some of these widgets can help you do unit tests on the PyMC3 model. That would be not just a nice demo. I can actually see it being like genuinely useful. Like that would be more than a toy, I think. Someone else needs to write it though, because I can imagine you would have to dive a little bit more into the internals of PyMC, and it's been a while since I've gone there. Oh, and I forgot about that. Yeah. So, okay. So, oh my God, how could I forget? So people are now asking like, hey, Vincent, that's great. You have this given stuff, but we've got stuff from Judea Perl too, right? So, can I have a do operator maybe? And the answer is yes. Okay. And to explain the do operator, I have to go back to the whiteboard. So, okay, back to this. This thing works, right? But then some people, like, and I also started thinking about this later, like, some of these conditions, like if something is given, that is different than saying, hey, I'm enforcing something. Let me explain that. So suppose that I've got a probabilistic graph that looks a little bit like this. And let's maybe have it go a little bit like, yeah, let's do a little bit like this. So let's say, for example, this is the probabilistic graph. And I could say something along the lines of, okay, this guy is given. And because this guy is given, I can propagate knowledge forward, and some of that actually goes backward as well, because by knowing something about this guy, we can also update our belief about the guy that happened before. But there's also another operation that I can do, and that's the do operator. So the do operator is different. So normally, when you're saying something like, oh, something is given, then you're saying, I'm looking for situations that were similar to this, and from there I'm going to infer. But the do operator basically means, oh, I'm going to pretend that I've got a magical hand that can keep everything of the situation the same, but I'm going to totally influence that artificially, which is a different claim. So for example, I could say, like, you can say something about, oh, I've got two hands, and given that my right hand is of a certain size, that tells you something about the left hand as well, because I'm the same person, right? Like, that's always been the case. But let's now say I'm going to artificially increase this hand. That's a different claim. And because this has been artificially increased, it doesn't say anything about the distribution of my other hand. Like, that's kind of the thinking. That's a different operator we can come up with here. And the way that the inference would work is when you apply a do operator in this particular graph and in this particular case, this would still propagate forward, but you're not going to be propagating in this direction anymore because you've applied the do operator. Read Judea's books if you're interested in knowing the full thing there. It's been a while since I read that, so I want to keep it at here. I just want to make the intuition appear. But that is a different operation because you're asking a different question. Like, what would happen if I were to really intervene here as opposed to asking something about the actual distribution that's under the hood? And in that case, can we still come up with something that works over here? And the short answer is yes, because I need a condition over here. Oh, and what I can do for that condition is I can just say, okay, do smoke instead of just smoke. But from an API perspective, that function do is still touching something that knows about the entire graph. So internally, I can still conjure up the entire query that's needed. And it also happens that the library that I'm building on top of has support for it. So yes, you can apply the do function if you're so inclined. I didn't really find a nice example to show with the do operator. And it's also, I will immediately admit, the least tested thing in this entire library. Like, I have looked at some of these distributions and I've done some like back of the envelope calculations, like, hey, does this feel about right? And for the normal queries that I've thrown at it, it seems to be pretty like on the spot. And like, these graphs have the shape that I would expect it to, and these graphs have the shape of things that I've also done in the past. So like, I'm pretty confident I've got like a couple of things right with these normal queries. The do operator though, it's in there. Never tested it. Don't bet the company on the outcome of that operator. But yes, you can also do the do operator. The API allows for that, which I think is just super nice. We can also allow for other operators, by the way. But the main one in the literature is the do operator. Oh, and we have people actually dialing in from the Netherlands. Well, I suppose that that's also allowed. Thanks for joining. So this has been a good live stream. Hopefully people thought this was interesting. Again, I'm pretty sure I've really gotten the Bayesian people in this live stream over here, and what I really hope is that people are sort of maybe not so much inspired to use this library, because again, it's something I've made on a whim with a lot of vibe coding, and I don't really know if I'm going to be able to properly support it. But to some extent, I think that's fine, because the main point really, like if you are gonna, you know, really go home with anything here, it's not really about the syntax or the code. It's a little bit more of, oh, you can make a DSL and that's great, but maybe if we want our field to go forward, we have to talk about not just domain-specific languages, but also domain-specific interfaces. And if anything, that's been the main thing that I think Mimo has really made me think differently about some things. The ability to just, throw in a widget and have that be combined with Python code, like that opens up so many doors. Next week, I'm also going to release there's a tutorial video on our channel where I have this paint widget that allows me to draw. And oh, you can actually have drawings sent to an LLM, and that can be your main way of communicating. Oh, that's actually just kind of nice. And building that demo is really quick because I'm pretty good at making widgets, but also I've got Mimo at my disposal. And so all the interactive stuff and therefore all the environments that I want to make are just, maybe an hour of work, but a little more. So having said all this, hopefully if there are questions, I'm going to stick around, but I also think if people want to get back to their work because we started late, that's also totally fine. Yeah, people are talking about PyMC3 mostly, it seems, in the chat. So oh yeah, that's actually like a final demo I should show. People are talking about like, hey, that's a cool Mimo demo. The really cool demo, like my face over here, there's like a little button over there that allows me to run this not just in edit mode, but in app mode as well. This guy. So let me just click it. You can actually also just turn all. You need to zoom out for this, and I didn't do any layout stuff here. But you can also like turn this into a proper app, right? So these interface elements, you can build this in such a way such that the end user really just sees, like you can actually turn this into an interesting form where the user doesn't get to input the DAG, but the user does get to input everything that's known right now. And then there's a little thing on the side that says, okay, then these are the things that we now know about this user. Like way back in the day, I had this one use case about, hey, I remember having this use case for like an airport, and they really wanted to know, hey, is this passenger going to be late? Yes, no. And there's a few things that we know, but the stuff that we know isn't available all the time. Like it comes in a stream of events, basically. So a nice way of dealing with missing values then was to come up with some sort of a probabilistic graphical model. And this was done 10 years ago, and I built it in R, but like the idea of modeling it that way, having some sort of good screen for that was definitely, kind of a cool trick, kind of a cool demo, and you can definitely build that inside Mimo. Yeah, so let me just check final call for questions. People are talking about PyMC3 stuff. Great. If this sounds interesting and if people want to continue this conversation, definitely join me in the Mimo Discord. That's where I tend to hang out, and we can make a channel if people want to exchange notes. And also, like, if you have Mimo demos eventually that end up doing something with this Bayesian stuff, let me know, because I will retweet it, because I do think that there's an LLM hype happening right now, and unfortunately that also means that a lot of these data science talks at PyDatas, they are less and less about the Bayesian stuff, and I do think that there's still a good place in the world for the Bayesian way of thinking about it, and it'd be a shame if we ever sort of lost some of those ideas. Like, that's something I'm actually kind of personally eager to make sure that we keep that around, so we put it that way, because otherwise we lose out on some great ideas. Having said all of that, though, this has been a great stream. Thanks everyone for joining. Have a great afternoon. Have a great weekend. Next week, I am going to come back, and I think that I'm going to do a live stream about interactive environments for batch jobs. So one thing to think about is you can kind of see a graph in Baseland, but what if your Python program is also a graph? And what if we want to log that in an interactive way, such that in hindsight, I don't know, maybe you don't want to look at a log file. Maybe you want to have some sort of environment that can just tell you, oh, this is basically what happened in your entire Python program, and you can really see what is happening. What if we had like a system that could sort of show you the flow
of a Python library. So I'll show you the flow show. I'm sure you can Google it if you want to have a preview. But next week, I'm probably going to talk about how that was implemented if people are interested. You all have a good one now. Stop stream.